Okay guys, so in this lesson we focus on the definitions of concepts of vertical projectile motions. Okay, so let me just write it down. We're focusing on definitions of concepts. Okay, so ladies and gentlemen, I assume at this stage you've got something to write. So as I'll be talking, you can just listen. Remember guys, I always advise you to first watch this lesson without having to write anything. Watch it for the first time, just listening. Watch it for the second time, trying to listen and understand, and when necessary try to apply your mind, and watch it for the last time where you write down some notes. Okay, so what I'll be doing in this case, ladies and gentlemen, is just to give some definitions of the concepts in words. Okay, and again, definitions in the form of an equation where necessary. Ladies and gentlemen, please do allow me to say it's very much important that I say it's very, very much important, because, ladies and gentlemen, what I'm about to say is massively important. Okay, a day without learning something new is a day wasted. So that means please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen. So without any waste of time, let's start with the first concept. Obviously, ladies and gentlemen, from the previous lessons I've spoken much about acceleration. Okay, so in terms of an equation, what is an acceleration? Let me just write it down. Acceleration. So I'm just going to give a definition in words, but before I do that, in terms of a formula, ladies and gentlemen, acceleration, it's represented as delta V over delta time. Very, very much important, ladies and gentlemen. So in words, acceleration is the rate of change of velocity. As simple as that. I hope you can write that down, ladies and gentlemen. Is the rate of change of velocity. Okay, so ladies and gentlemen, in words is the rate of change of velocity. In terms of an equation, this is how it is represented. Okay, so remember guys, at all times, the moment when we say the rate, okay, just know that it's something over time. Very, very much important, ladies and gentlemen. It doesn't matter whether we say the rate of whatever that it is, but the moment you hear of the word, just think of something over time. Okay, so obviously if the definition starts with the rate, it has to be the rate of something. Okay, in this case is the rate, which means over time, of change in velocity. Okay, so remember this thing, ladies and gentlemen, in Greek it's called delta. Okay, delta, which simply means change. Okay, so change, ladies and gentlemen, it simply means final minus initial. Okay, that is the change. So you can have change in velocity, which will mean this is going to be v final, this is going to be v initial, which is delta, ladies and gentlemen, which is a change of what? Of velocity. Okay, so in this case, when we say the rate of change of velocity, we're simply saying the rate of change of velocity. What is this, ladies and gentlemen? This is what we call an acceleration. Okay, so You might find that in some formulas you've got delta t. Okay, so it also means change in time, which simply means time final minus time initial. Okay, so this can be represented as change in t. Regarding the initial and the final, ladies and gentlemen, let's say for example you've got a car which is stationary there, okay, and you drive such that you reach your top speed. Okay, so obviously there you are, ladies and gentlemen. You're driving from 0 to let's say 60 kilometers per hour. Okay, so when we talk about change in velocity, ladies and gentlemen, that means this is your initial velocity where your car was stationary. Okay, so obviously when it's at rest, or when it's at station, or when it's stationary, its velocity is 0 meters per second, 0 kilometers per second, and you drive up until you reach your top speed, which is 60 kilometers per hour. Okay, also here, ladies and gentlemen, 0 kilometers per hour. So if you were to substitute into this formula, that means this is 60 minus 0. This is 60, which is your velocity final, and this is 0. So it's more like final refers to the finish or last part, and then initial represents the start of the scenario. Okay, so same with time. Remember, because you're starting at this point, then it means time it's, let's say, 0 hour, okay, or 0 seconds, whatever the unit of time is concerned in that particular scenario. And again, let's say here it's 1 hour or 60 minutes or 360 seconds or whatever time it is. Okay, so that will mean whatever time minus 0. So obviously that whatever time is the final time minus the initial time, which is 0. Okay, so ladies and gentlemen, at this stage, please do not stress that much about this formula. You just need to know that acceleration is equal to delta v over delta time, which means rate of change of velocity. Okay, very, very much important, ladies and gentlemen. So I'm just going to erase all of this information. So that's what you need to know as far as the definition of concepts is concerned under vertical projectile motion. Very, very much important, ladies and gentlemen. So now let's talk a little bit about average speed. So ladies and gentlemen, average speed, okay, in terms of an equation, you can just say V. Remember, ladies and gentlemen, V or S, it represents the speed. Okay, so let's just say S, which refers to the speed, is equals to distance over time. Okay, so this is how we represent the speed, not just the speed, but average speed in terms of an equation. Okay, very, very much important, ladies and gentlemen. So in words, speed is the total displacement per what is it, the total distance traveled per unit time. Okay, very, very much important, ladies and gentlemen, the total distance traveled per time. So you can just write it down as part of your notes. So it's the total distance traveled per unit of time. Okay, so ladies and gentlemen, straightforward and easy as that. Okay, again, ladies and gentlemen, let's talk about average velocity. Okay, so in terms of an equation. Let's just say v, which refers to the velocity, it's equals to, you can just say x over t. Okay, very, very much important, ladies and gentlemen, which means average velocity is the total displacement per unit time. Okay, so the formula is also simple and straightforward. So in terms of definition, average velocity is the total displacement per unit time. Okay, very, very much important, ladies and gentlemen. So now that we've got an average speed and an average velocity, can we just try to differentiate the two in terms of the definition given by given in terms of weights? In this case, on average speed, we've got the total distance traveled per unit time. Okay, whereas when it comes to average velocity, we talk about the total displacement per unit time. So the difference in this case, ladies and gentlemen, is that in this case we are talking about the total distance traveled. Okay, in this case we're talking about the total displacement. Okay, I hope as I continue with the explanations you will understand what is the difference between the distance and the displacement. Okay, can I just quickly try to explain the two, ladies and gentlemen? Let me just start with the displacement. Okay, very, very much important, ladies and gentlemen. I'm just going to quickly explain the displacement, and thereafter I'll explain the distance, and we'll try to just quickly explain the difference between the two. Okay, so ladies and gentlemen, remember, I assume at this stage you're just watching this video just so that you familiarize yourself with the content of this lesson, and you're going to watch it for the second time where you try to apply your mind as I've indicated, and lastly watch it for the last time where you write down the notes. I am telling you, ladies and gentlemen, if you do that, you will be fully ready for your first test, where you'll be dealing with questions related to this chapter. And most importantly, ladies and gentlemen, especially when I do lessons for matriculants or lessons for grade 12s, I try to firstly combine either the grade 10, 11 and 12 content, such that you don't have to go through your grade 10 lessons just to remind yourself. So this is just a combo, ladies and gentlemen. In one lesson, I try to combine all the information that is provided in grade 10. Obviously, if I remember very well, when it comes to vertical projectile motion, I think this chapter it's only in grade 10 and 11 12 if I'm not mistaken. So my lesson for grade 12s will include a grade 10 information together with grade 12 information. So do not be surprised when something looks like it was only being taught in grade 10 and I'm still teaching it in lessons for grade 12s. That is because you just need to watch this lesson, then it takes you back to grade 10, and again it includes information in grade 12. So towards the last lessons that I'll be doing, that's where I'll only be focusing in grade 12 stuff. Okay, so it's grade 10 plus grade 12 stuff, and then they are narrowing as I do more videos, and then towards the end I'm only focusing on grade 12 stuff. That's why it's very much important that when you watch my videos, do not watch from the videos in the middle. Just start from the very first videos that I've done, okay, because it contains the information for both grades. then watch all the videos all the way up to the last video. Okay, very, very much important, ladies and gentlemen. I hope you fully understand that part. Okay, remember guys, displacement, it's what I'm about to define. Okay, so the displacement is the change in position of an object from a point of reference. Okay, very, very much important, ladies and gentlemen. I think, I'm not really sure. Okay, let me just write it down. Okay, is the change in position of an object from a point of a reference. Okay, you just write the correct spelling over there. Ladies and gentlemen, the length and direction of the straight line drawn from the beginning point to the end point, that's what we call displacement. This information, it's given in grade 10, of which it's very, very much important to always remember when you get to grade 12. Okay, guys, another tip. Remember, if you haven't covered, not necessarily covered, but otherwise, if you forgot some of the information that you learned in grade 10, okay, or in grade 11, do not assume that you will understand when you get to grade 12, because this information is continuous, ladies and gentlemen. For example, this is a chapter which is in grade 10, and because it's not there in grade 11, it doesn't necessarily mean that when you get to grade 12, you'll be doing something completely different from what you learned in grade 10. Okay, it's just a continuation of what you learned. So in grade 10 is the basics. In grade 12, you apply your mind. It will be on a different level. So at all times, please make sure that in case if I've done a lesson where I didn't include either the grade 10 and 11 stuff into a lesson for grade 12s, you just try to go back to the lessons that I've done for grade either 10s or 11s and watch that lesson. Okay, but in this case, luckily, I've got everything in one lesson. Okay, so ladies and gentlemen, can I go deep into explaining the displacement? Let's say this is your home. Okay, this is your home, and then you're going to a shop. Okay, so you're going to the shop to buy some bread. Okay, and in between your home and the shop, maybe few streets, after one street there's a tree, and then this is another street, this is another street, then you get to the shop. Okay, so ladies and gentlemen, as far as displacement is concerned, it means from the starting point, which is your home. Okay, you walk or you drive, you ride a bicycle. If you're able to drive, then you drive to the shop, and that distance, let's say it's let me think, let's say it's excuse me, ladies and gentlemen, let's say it's 100 meters. Let's say it's 100 meters. Okay, so you walk 100 meters, you get to the shop. Okay, then you walk back from the shop towards your home. Okay, so in terms of displacement, ladies and gentlemen, if for some reason I saw you when you were leaving your home, then I go somewhere, while I'm heading to wherever I'm going, you walk to the shop, and then you are now on your way back. And by the time when you get somewhere there, just along that tree, maybe I see you again. So let's say this tree, ladies and gentlemen, let's say this tree, it's about 30 meters away from your home. Okay, so according to me, ladies and gentlemen, it will be as if you've only traveled from there to there. According to me, when I see you for the second time, while coming back from wherever I was. Okay, so that is the displacement, ladies and gentlemen, which is the change in position of an object from a point of reference. So this is a point of reference. I saw you there. First time when I saw you, you standing somewhere there. You're about to walk to the shop. You went to the shop, and now on your way back, I see you for the second time. But by the time when I see you, you're somewhere there. So in terms of displacement, ladies and gentlemen, according to me, it's more like you've only traveled that distance, because it's that 100 minus this distance, which is obviously 70 meter. Okay, so if I were to calculate the displacement, ladies and gentlemen, it's that distance that you traveled minus that distance from there to there, which is 70, and this is equals to 30 meter. So the difference between displacement and the distance is that the distance is the total length of the path traveled by an object, or traveled by this person who went to buy the bread. So now the question is, what is the distance traveled? So the distance traveled, ladies and gentlemen, is that 100 plus that 70 that you traveled on your way back. So ladies and gentlemen, I'm not really sure if it now makes sense. So that means the distance is actually the total distance is the total I've just explained it, ladies and gentlemen. Distance is the total length, okay? Is the total length traveled by an object, okay? So, ladies and gentlemen, the total distance is that 100 that you traveled. So let me just say the distance will be equals to that 100 that you traveled plus, remember the total, ladies and gentlemen, the moment someone says total, it means you just add whatever that it is. Okay, just add. If it's velocity, if it's the total velocity, you add velocity 1 maybe plus velocity 2 plus whatever. But in this case, we're talking about the distance. So if we say is the total distance, remember there's a relationship between the distance and the length, one and the same thing. Okay, so ladies and gentlemen, what is the total distance traveled? You traveled 100 meters, okay, plus you also traveled 70 meters. So we say 70, which is equals to 170 meters. Can you now see the difference between the distance and the displacement, ladies and gentlemen? So another way of distinguishing the two is to say distance is a scalar quantity, whereas displacement is a vector quantity. So a scalar quantity, it means it's a magnitude that has a value. Let's say, let me rather say it's a quantity that has a value or a magnitude only. So a vector quantity, ladies and gentlemen, it's a quantity that has a value or a magnitude and direction. Okay, so ladies and gentlemen, if we talk about distance, it means you just traveled 170 meters. Okay, but with regards to a displacement, it's like you traveled only 30 meters in that direction, which could be referred to as eastwards or to the right. Okay, so according to me, ladies and gentlemen, in terms of displacement, it's more like you just moved from that point to that point in that direction. That's when we talk about displacement. In terms of distance, we take into consideration that you went all the way up to there and you returned, because we talk about the total length traveled. Okay, very, very much important, ladies and gentlemen. I assume you fully understand this part. Okay, so now let me move to the next let me see, ladies and gentlemen, up to which point do I erase all of this information. Let me just erase it up to that point, just in case if I need to refer to something between those two. Okay, but otherwise do not worry that much, ladies and gentlemen. So now remember, we have spoken about average speed, and again we have spoken about average velocity. So now let's talk about speed and not average speed. Okay, so obviously, ladies and gentlemen, the speed in terms of equation, you can just say speed is equals to change in distance over change in x. Let's just say change in x over change in time. Okay, so remember guys, that x, it represents the distance. Very, very much important. Okay, it represents the distance, and I think I've just explained what a distance is, the total length. Okay, so in terms of speed, we are talking about distance over time. And remember guys, speed is a scalar quantity, which means it's a quantity that has a magnitude or a value. What is a magnitude, ladies and gentlemen? It's just a number for a speed. Speed can be 3 meters per second. Okay, so this is the magnitude of that particular speed, or is the value of that particular speed. So when we talk about a vector quantity, of which I'm going to explain shortly, that's when you have magnitude and a direction, which could be to the right or eastwards, north, south, or to the left, or whatever the case may be, just so that you are able to differentiate between a scalar and a vector quantity. Okay, very, very much important, ladies and gentlemen. So now let's define speed in weights. Okay, so ladies and gentlemen, speed is the rate of change of distance. Okay, is the rate. Remember, when we talk about the rate, anything over time, the rate of what? Of change of distance. Okay, rate of change of distance. Okay, very, very much important, ladies and gentlemen. That's why it's important for you to write that delta x. That delta comes from that weight change. Okay, over, at all times you can just write delta t when we talk about the rate of something. Okay, so ladies and gentlemen, let's now define velocity. Okay, velocity. So the velocity, ladies and gentlemen, is the rate of change of position. Okay, is the rate of change of position. Okay, so obviously, ladies and gentlemen, in terms of an equation, so you can just say v, it's equals to, remember the rate, it will be obviously anything over time. In this case, that anything is the rate of change of position. So change of position, delta, because of the set change, position can be represented by x. Okay, so as you've noticed, it seems like velocity and speed can be represented in the same way in terms of an equation, but in terms of definitions in words, they're different. What makes them different is because when we talk about speed, ladies and gentlemen, we talk about the distance. Okay, we talk about the velocity, something that has to do with the position. Okay, and there's a relationship between position and displacement. Okay, there's a relationship between the distance and a length. Okay, remember, even though all of them are measured in the same units, which could be a meter, millimeter, a centimeter, kilometers, whatever the case may be. Okay, very, very much important, ladies and gentlemen. So guys, this brings us to the end of definitions of the concepts. Okay, I hope you fully understood that part. Remember guys, a projectile is an object upon which the only force acting is the force of gravity. I suppose I've explained this in the previous lesson. Free fall, we talk about motion, which is when the object falls. Okay, and obviously as it falls, the only force acting on the object is the force of gravity. Very, very much important, ladies and gentlemen. Okay, so guys, this brings us to the end of this lesson. So on the next lesson, what I'll be doing, ladies and gentlemen, is to talk more about equations of vertical projectile motion. Okay, so that's where I'm going to explain in detail those formulas, and again the difference between formulas used in grade 10 versus the formulas used in grade 12. As soon as you understand that part, then going forward we only talk grade 12 stuff. Okay, because this lessons falls under all the lessons that I do for grade 12s. But it was very much important that we combine grade 10 and 12 information so that you don't have to restudy this content using grade 10 textbook. Okay, so I hope to see you on the next video. Guys, my name is Desmond and I'm out for now.